Okay guys, welcome back to First Person Radio. Today is a bit of a crossover with more general prepping because we're going to be talking about solar panels and solar charging. So what I have here is I have a 100-watt solar panel. It's not mine, I actually borrowed it. In addition to that, I have the solar panels I typically use, which are these little power film flexible solar panels. I love these. They're a lot more expensive for the same amount of power. So that's the drawback, but the advantage is they are pretty much indestructible, like you're not going to break them, and they're nice and portable. This guy's too big to carry with you backpacking, but might do good in a backyard or something like that. So what we're going to talk about is we're going to talk about how to use these to charge lithium batteries. What I have right here is my lithium iron phosphate battery. This is a 15 amp hour. This is maybe something I'd use for like a 100-watt rig. I probably wouldn't use something this large for portable, but it goes pretty well with this 100-watt solar panel. And to charge lithium batteries, you are going to need a proper lithium battery charger, right? Something that's designed to charge them well and safely. The two things about charging lithium batteries that you need to worry about is you need to worry about the maximum voltage and the maximum current. So what you can do is you can buy a constant current, constant voltage charge controller. That's this guy right here. This one is, $10 off of Amazon or $15 off of Amazon, I forget. There's a million different varieties of them. Some of them come with a display on it so you can measure the output. I like to have the display on it, but for something smaller, you can get one without and make it even more compact. And then you have these two adjustment potentiometers up here. One of them adjusts the voltage and one of them adjusts the current. If I could get my dang camera to focus. If you look really close, you can actually see there's text on the PCB underneath it. This one says CV and this one says CC, but it's all kind of covered. So you kind of have to just twist them and figure out which one's which. So what you do is you set your constant voltage to the fully charged voltage of your battery. So this one, the charging voltage on this one is about 14.4 to 14.6 volts. So I would set my constant voltage to that. My constant current I would set to the maximum allowable current that my battery can take. If the charger is capable of handling it, right? This is a fairly small charger. Technically it'll do 5 amps, but it won't do more than maybe 3 amps of current continually without overheating. So you set that to whatever amount of current is your battery can take or your charger can take, whichever is the weakest link. And then once you do that, you just plug it in, and what this does is there's a couple different kinds. This one is a buck regulator. So this takes a high voltage and steps it down. That's what the buck means. So it's only capable of going from high voltage to low voltage. So whatever solar panel you have has to be higher voltage than the battery you're charging. If I have a 12-volt solar panel and a 24-volt battery, I won't be able to use a buck regulator on it, right? The other kind of regulator you can get, well, there's 4 kinds. Another kind is the boost regulator that goes from a low voltage to a high voltage. These typically don't work well with solar panels. They're great for stuff that you plug into the wall or stuff that you run off of a battery and you need to boost the voltage up for some small electronic project, but they're not great for charging. Then they have buck boost regulators that do both. These also don't work well with solar panels. So you really want a buck regulator or the last type. The last type is designed for use with solar panels and they work great for it. It's MPPT, maximum power point tracking. And this one is one of those, and it's also a lot beefier. I think I paid 30 or 40 bucks for this one, so it's a little bit more expensive. But this one has my constant current for the maximum battery current, constant voltage for the battery voltage, and then it has this one here, the MPPT. I know some of these do this automatically. This one doesn't. I have to turn this dial myself, but this sets the lowest voltage that it'll drag the power supply down to. So you turn this to be the most efficient voltage for your solar panels to operate at, and then you'll get a little bit more charge current out of it. So let's do a little demonstration. I've got my battery here. It definitely needs charging. If I plug in one of these charge regulators, let's use the buck regulator first. This is the output. And this is a surprise tool that will help us later. Let me set the screen here to show voltage. So my battery voltage here is 13.2 volts, it looks like. Yeah, 13.3 volts. I'm sorry you can't see it very well. And I've got no input current right now. So let me plug my solar panel in. Now, this is an SAE connector. I don't have an adapter for power poles. If it was mine, I would cut this cable and put power poles on it, but it's not, so I'm just using alligator clips. And we are getting, how much are we getting in amperage? Let's see here. 0.63, is that right? Well, that's not as much as I would have thought. Oh, the sun has started to set, and it's started to cover our solar panel. Just that little bit of shade at the bottom of the solar panel will really reduce the amount of current you get. Your solar panels really need to be pointed directly at the sun and in full sun. I mean, if they're not pointed directly at the sun, they'll still work, not as well. But what'll really kill them is a small amount of shade. So try and keep them not shaded at all. That's also why if you have several solar panels, you should put them in parallel and not in series. If you put them in series, you stack their voltage together. But if one of them gets shaded, it'll really reduce your efficiency. Okay, so this is 3.21 amps is what I'm getting with the buck regulator. That works fine. Let's try the MPPT regulator. This one is supposed to be more efficient. And I've noticed it does seem to be a little bit more efficient. Let's find out what we can do here. Oh, that's much easier to read. So my solar panel voltage is high before I have any load on it. And 16.45, 16.49 is the voltage that I set using this guy, the MPPT. And as I adjust this, you can see I get more or less efficient, right? I start going too low in voltage, it gets less efficient. I keep adjusting that until I get maximum power out. About 16.7. 16.8, something like that. And then I get a little bit more voltage, right? So I was at 3.2 with just buck. This is 3.5. So not a huge difference, but that's like 10% more efficient. And you might see, changes to that depending on your particular setup and how much sun you're getting and what your panels are like. I haven't done, exhaustive testing on it, but it's a little bit of a benefit. The other benefit of this is that this is a buck boost regulator as well, so it can take a low voltage and step it to a high voltage. But again, this MPPT setting would have to be set right, so they're a little more complicated to run. I'm not sure if it is strictly necessary for portable setup. Usually MPPT chargers are a little bit bigger and beefier. They're for guys who have more fixed setups that they're trying to squeeze every last bit out of. Now, what do I use? So, I used to use a buck regulator, and it worked well for me, except for situations where I was trying to power my radio from a lower voltage into the battery pack. So these are 14.4 volts fully charged. I wanted a general purpose power supply that I could use to charge off of almost anything. So I built this. This will let me charge off of solar panels with a buck regulator only. And it will also let me charge off of batteries that are lower voltage than my ham radio battery, like my car, right? So my car, when it's running, is 14.8 volts. But when my car is not running, my battery is down to like 12 volts. So I can't plug my radio into my car and charge it unless my car is running. With this, what I've done here is I've taken, so on the inside I have, this is my buck regulator. It's a very small one that doesn't have an LCD screen on it. There's my constant current, constant voltage setting right there. And in switch position number 1, the power goes directly into the buck regulator and right out. and then this is just a voltage and current meter on the other side here. I have them back to back. This one reads current, this one reads voltage. So in setting number 1, it's just a straight up buck converter, goes right through there, high voltage to low voltage, and I can get my readout. And that's great for solar panels or for power supplies that are higher voltage. If I'm charging off of my battery, I flip my switch to setting number 2, and then what it does is it goes instead to this converter here. This is a boost regulator, right? This steps voltage up, and I adjusted this little screw so it steps up to about 15 volts. And then after the boost regulator, then it goes into my buck regulator, which steps it back down to my 14.4. So I can have 12 volts come in, goes up to 15, down to 14.4, and I can charge my ham radio battery off of a lower voltage battery. And this will actually work with almost any source of DC current above a minimum voltage. I might have to crank down my current so that whatever battery I'm plugging in can supply it. I could clip this to a 9-volt battery and draw just a little bit of power off of it, or a 6-volt lead acid from like a trail camera or something. I could even I could even cut up any power adapter I find and use alligator clips and use this to convert the voltage appropriately. I might make a video on this later about how to just kind of like scavenge electricity that way. The only other thing is this is a diode right here. This is like a one-way valve for electricity, so that when my buck regulator is running, it doesn't backfeed and use up some power charging the circuitry of the boost regulator. I'll talk about those later. That's the surprise tool that will help us later that I tossed in the bucket there. So this, I think, is a good compromise for like a one-size-fits-all, toss it into my go bag to charge my radio off of anything I can find. It just takes a little bit of soldering and assembling, and you have to know what you're doing with it to get it to charge your batteries properly. This guy would be great. This MPPT charger would be great for like a more fixed position setup, like in your backyard with more solar panels. Okay, so the last trick, especially for something fixed position, is this guy. Again, I mentioned this is a diode. So what this does is this blocks current from going in one direction and allows current to go in the other. If you look on the diodes, there's a stripe on them, and that stripe indicates the negative side, and power flows positive to negative. So the red is positive, so that tells me that it'll let electricity flow in this direction, but not in this direction. So if I put this on the output of my charge controller, well, first let's demonstrate what happens if you don't have one. So this guy is running, right? It's using a small amount of electricity to operate, which is great because it's pulling in a lot from the solar panel. But if my solar panel is dark, right, it's nighttime, I still have some power being used to operate this device. It'll consume a small amount. These will actually still light up the LCD screen, and everything will look like it's operating normally. It's just sucking down, a few milliamps of power. What you can do, in fact, let me switch to that one because it's a little more clear what's going on. So this guy is powered right now. There's no input current. It's just draining my battery. So as soon as the sun goes down, my battery starts to die, right? Because my charge controller is still alive. What you can do is you can take this diode, this one-way valve, and put it on the output. Now this diode has a little bit of voltage drop. This particular one, I believe it's about 0.3 volts. So if I wanted this to be at 14.4 volts, I would need to set my charge regulator 0.3 higher than that. So 14.7 volts here. And I'd want to measure it with a multimeter to make sure that that voltage drop was accurate. But now what happens is I plug my solar panel in. My charge controller is powered, everything's running normally, my battery is getting charged. A little bit of power is lost here for that 0.3 volt drop, but not a whole lot. And then when the sun goes down, my charge controller gets shut off because it doesn't have any source of power anymore, because the power can't go back from the battery into my charge controller. And then when the sun comes right back on, or sun comes up in the morning, it comes right back on. So this is just a way to avoid losing power by running your charge circuitry even when you have no input current. Some solar panels, by the way, will backfeed power as well. If your battery is hooked directly to your solar panel, it'll go back through the panel and waste energy that way, and it's actually really bad for your panels as well. A lot of those little junction boxes on the back of those solar panels will have a blocking diode installed. So if you see a solar panel talk about having a built-in blocking diode, that's what they're talking about. But it won't do anything to stop your charge circuitry from sucking your current down. So having a little diode is nice. And you can take it off if you don't need it. That's why I put these two little Anderson power poles. And I bought the diode itself. It's just this black body with two long wires, and I crimped them into the connectors, and I assembled it, and then the ground was just a straight jumper wire. So it's kind of nice to have. All right, so what I could do right now is I could pull out these power film solar panels and demonstrate charging with them. I might as well. So this one is a 12-watt power film, right? Not a lot of power, but it should be enough to keep a station running for a little bit. And they're nice and flexible. I love these guys. And they come with some weird connector, I forget what it is, but I cut it off and put power poles on the end. So I can just plug this directly in, plug it into the battery, and I do get a little bit of a charge. Not much now because the sun's going down, and because these are not angled towards the sun. That's the other disadvantage of the flexible panels, is it's a little harder to angle them towards the sun properly. But let me just hold them to see what we could expect to get. Maybe 0.3 amps, 300 milliamps. That's enough to run my radio and receive. I'd be draining my battery on transmit, but keep in mind, the sun's going down. I could also take two of these and wire them in parallel and get double the current. And that's how I'd recommend wiring your solar panels. If one of these gets shaded off and stops putting out full current, as long as the other one has still got sun, it's fine. If you wire them in series, the electricity has to go through one panel into the other and then into your charge controller. So if one of them stops getting sun, it actually drags the other panel down, right? That one panel has to now force electricity through the panel that's shaded. So that's why you should usually try and put them in parallel instead of in series. All right, well, I think that is a good first glance, at least, of solar charging. So keep your panels pointed directly at the sun. Get a buck regulator or a MPPT regulator to charge your battery. Set the current and the voltage appropriate for the battery, the voltage to the maximum charge voltage and the current to whatever your charge controller or your battery can handle, whichever is less. And that's about it. You can use the diode trick to avoid wasting a little bit of power on backfeed from the battery into your charge circuitry. All right, well, I hope that was helpful. Let me know if you have any questions or if you want me to demonstrate anything else. I will see you guys later.